We hear about models like Claude and GPT pretty much every single day. But have you ever stopped to think about what it actually takes to build one? I mean, from the ground up. We're not talking about sci-fi here. The reality is a gritty, high-stakes engineering challenge. So today, let's go inside the engine room and see how these things are really put together.
So the big question is, how do you go from basically nothing, a blank slate, to an AI that can write code, whip up a poem, or answer some ridiculously complex question? It's not magic, right? It's a process. And it all kicks off with this one simple but unbelievably powerful idea that has pretty much fueled this entire AI revolution.
Okay, welcome to the engine room. This is where it all happens. And it's not some clean, shiny lab. It's a place of brute force, of massive, massive scale. The core process behind everything is called pre-training, and it's the hidden engine that makes all of modern AI tick. And to guide us through this, we've got a real insider, Nick Joseph. He's the head of pre-training at Anthropic. This is a guy who's one of just a handful of people on the planet who has been on the front lines, actually building these giant AI models from scratch.
Now, you might think that all this complexity is built on some super advanced, complicated theory. But what's so wild is that this whole revolution was kicked off by a single idea. And it's an idea that is shockingly simple, but so powerful.
And this is it. This is the whole trick. Pre-training. You basically show a model a huge chunk of the internet. We're talking books, articles, websites, everything. And you just ask it over and over and over again, what word comes next? That's it. It sounds almost too simple, but when you do that billions, even trillions of times, something amazing starts to happen. The model doesn't just learn language, it starts to build a representation of the world itself.
And that simple idea created this powerful engine of progress. It's a feedback loop that has been driving AI forward for the last 5 years. You train a better model, which lets you build a more useful product. That product makes more money, which you then use to buy more computing power. And with more compute, you go back to step 1 and train an even better model. This scaling loop is the secret sauce.
So here's the crucial takeaway. For a long time, the biggest lever for making models smarter wasn't some clever new algorithm. It was raw, brute force computational power. As Nick Joseph puts it, you can tweak all the little details you want, but at the end of the day, just throwing more compute at the problem makes the models better. It's kind of that simple.
But here's the catch, and it's a huge one. It's easy to say just throw more compute at it. Actually doing that? Well, that's where the clean theory crashes head-on into a messy, brutal, and often deeply frustrating reality. This is where engineering gets pushed to its absolute breaking point.
I mean, get this. When Nick Joseph was starting out, he felt like there were maybe 30 people. 30 people in the entire world who were working at this frontier. It was this tiny, almost secret club of engineers trying to figure out how to push things to this scale.
And this is where things get really wild. You know, if you're a programmer, the first thing you learn is the computer is never wrong, your code is. But at this scale, that rule just goes right out the window. Nick tells this story about a bug he just couldn't solve, and his manager just looked at it and said basically, yeah, the computer's probably just broken. And you know what? He was right.
And that really gets to the heart of the biggest misunderstanding about all this. We tend to think of building AI as a software problem, writing clever code. But it's not. It's a hardware problem. It's a full-stack, down-in-the-trenches infrastructure problem. It's about wrestling with the physical limits of the machines themselves.
I mean, look at what this job actually is. This is not your typical coding gig. These engineers are practically hardware detectives. They're trying to figure out data center layouts, hunting for one bad GPU out of thousands, tracing network lag between different rooms. They're even worrying about power supplies and capacitors. It's this high-stakes game where one tiny physical failure can bring a multi-million-dollar training run to a screeching halt.
And you can't just go download a tool to manage all this. The software didn't exist. These early teams at places like Anthropic had to build everything themselves, from the ground up. They were writing their own low-level code just to get thousands of computer chips to talk to each other, pushing the scale way beyond what even the biggest tech companies were doing back then.
So, just as they're starting to get a handle on this massive hardware puzzle, 2 new challenges, maybe even bigger ones, start to appear on the horizon. And those are data and alignment. All right, first up, data. Here's the potential problem. We are getting better at building bigger and faster computers, faster than humans are creating new, high-quality things for those computers to read. So the question is, are we about to run out of good data to train these models on?
And it's not just a quantity problem, it's a quality problem.
Think about it. As more and more of the text on the internet is written by AI, there's a real danger that future models will just be training on stuff made by older models. You could get this weird echo chamber effect, where the AIs just learn from their own outputs and slowly go a little crazy.
Now, the second huge challenge is something called alignment. This is the big one. It's the problem of how you make sure that a superintelligent system actually shares your goals. How do you make sure that when you ask it to do something, it does what you mean, not just what you literally say, especially in some unforeseen, catastrophic way?
Nick has a really great analogy for this. He says it's like building a car. Right now, the first and most important job is just figuring out how to put a steering wheel on it. Once we can actually steer the thing, then we can start to have a conversation about who should be driving and where we should be going.
So with these monumental challenges, from hardware to data to alignment, who are the people actually tackling these problems? Well, the answer might not be who you think.
You might picture these AI labs being full of PhDs in machine learning theory, but that's not really the whole picture. The real MVPs, the people in highest demand, are the engineers. As you can see here, the need for people who can actually build and fix these incredibly complex systems far outweighs the need for pure researchers.
So what's the most valuable skill you can have in AI today? It's not necessarily a deep knowledge of ML theory. It's good old-fashioned engineering grit. It's this ability to take a really hard, weird problem and just dive in to any level of depth, from the software all the way down to the hardware, and figure out what on earth is going on.
And that really is the true story of how AI is being built. It's not about a single eureka moment in a lab. It's an epic engineering saga. It's a relentless day-in, day-out quest to find and squash tiny, elusive bugs hidden inside the most complex systems humanity has ever created.
So as we're building these incredible systems that are getting more and more powerful, it leaves you with a kind of a chilling final thought. If all this progress really does depend on finding these tiny bugs, what's the one we haven't found yet?